thank the other people who worked on this project with me. This is actually part of a larger effort that RISC is putting out. If you are on the RISC listserv, which if you're not, please join. You've gotten emails including some summaries of literature on invasive species and climate change. And so that came from either the group at UMass that's going to talk next about sleeper species, or the group that I'm with at Cornell University, including the New York Invasive Species Research Institute and Carrie here, on warming waters and aquatic systems. So this is going to be a real short, kind of a little teaser, but we have handouts that are available on the table outside, so please grab one. Provide us with some feedback. I think we're going to continue some of these efforts in the future, and we'd like to know if they're useful to you. So first of all, there are a lot of implications of climate change on aquatic systems. Unfortunately, in a few minutes, I can't cover them all, so for now, I'm just going to be focusing on warmer water temperatures. Temperature is a key variable in aquatic systems that affects chemical, physical, and biological properties. As far as chemical properties, temperature affects water or solubility of gases. So in freshwater systems, warmer waters have less oxygen than cooler waters, but they can also allow some toxins to be more bioavailable, including lead and mercury. As far as physical changes, here's just one example. In the Great Lakes, we have a lot of changes to thermal and hydrologic regimes. And here in the Great Lakes, you can see the blue. This is years from 1973 to 2017. The blue are areas where we don't have any ice cover, and white is where there's ice cover. And you can see that although there's a lot of yearly variation, there is a marked decline in overall ice coverage. And this has huge implications on aquatic life. And then also, temperature affects the life directly. Some organisms can benefit from warmer temperatures, while others will be experiencing thermal stress. For example, some species of fish may feel a squeeze between those warmer, too warm surface temperatures and the oxygen depleted lower waters or deep waters. And just a couple things that we're seeing in the northeast already. Increased surface water temperatures, changes in lake ice. So that's changes in the duration and timing of lake ice, as well as that overall coverage. Also reduce lake turnover. And so this is a big one. Twice a year, many lakes experience turnover, and that brings up nutrients that support aquatic life up into the water column. Unfortunately, with warmer water temperatures, sometimes this doesn't occur, and this can have huge disruptions on aquatic life. Also, more intense algal blooms and more extreme flow regimes such as flooding and droughts. Now, there are huge ecological consequences. We've talked about some of them. I've mentioned a few. And for the next few minutes, I'm going to go through a couple specific examples in the literature that have looked at invasive species versus some of our native species, and looked at how warmer temperatures may be favoring some invasives. And then I'll talk about a couple management considerations. There's still a lot of uncertainty in this field. A lot more research is needed, but I'm just going to give you an idea of what some of the things that we found out are. First of all, there are species that will benefit from warmer conditions. For example, we have the invasive brown trout, which will compete pretty equally with the native brook trout at cooler temperatures. However, as temperatures increase, then the brown trout is able to outcompete the native. In addition, there are a lot of aquatic species that benefit and have increased growth rates under warmer water conditions. Under just a 4-degree increase in water temperature, curly pondweed doubled its growth rate. And Eurasian water milfoil as well is another one that can increase its growth rate under these warmer water conditions. They also have these longer growing seasons. However, I have to caution this response is species specific. We found a lot of cases where there were not any discernible differences in growth rate or productivity among natives and invasives. And so one example is the Eurasian water milfoil. While it benefits from warmer waters, broadleaf water milfoil did not show any discernible difference. And we have lots of species, we've talked about this a lot today too, that are limited currently by temperature. And now as water is warm, they're going to be able to expand their region. Asian clam is a good example of this, as well as water hyacinth. This is an important one that creates these giant monocultures and is on many watch lists in the Northeast. Now, under warmer water conditions, the water hyacinth has a much higher survival because it doesn't experience those really cold, extreme temperatures over winter. And then in spring, it's able to just rebound quickly and grow much more vigorously. And the last one I'll talk about today is the changes in these disturbance regimes that are important for natural and native species. This is rock snot, our didymo, and I just had a discussion over lunch about this one. I know, a lovely lunch topic, right? There were no pictures, it's okay. So ice scouring, the breakup of ice, and then the subsequent scouring of the bottoms of riverbeds helps remove, or is thought to help remove some of the rock snot. However, as ice is being reduced, or as ice coverage is reduced and this ice scouring is occurring less and less, the thought is that that is causing, allowing rock snot to again benefit, and as soon as spring comes, it's already there, it hasn't been removed, and it's growing much more vigorously, and it's expanding its abundance and extent. And that's a big one for water quality. Recreational fish or anglers definitely do not like this either. Nobody likes to look at pictures of it. And so then we have some management considerations. Again, we're still learning a lot about invasive species, aquatic systems, and climate change, but one consideration is to extend decontamination station seasons, both to match the longer boating season, as well as that longer growing season for these invasives. Also, engage with neighbors at lower latitudes and elevations to help identify species to put on watch lists. And then there are some potential ways that we can manage aquatic systems in order to increase shading or to directly reduce water temperatures, such as managing riparian buffers for shade, or also designing water retention systems such as wetlands to help reduce the temperature of water coming into our water bodies, especially from urban areas. And then also, this is a big topic today too, managing ecological resilience, trying to give pristine or native species in areas that are not currently infested a fighting chance, so that when these new invaders do move into their region, they have a chance to protect themselves, more or less. All right, so if you want some more information, please grab one of our lovely handouts and sign up for the RISC listserv. All right, I think I'm out of time, but if there are any questions, come find me.